A square-based box has surface area 96 inches squared. What height and width should we choose to maximize the volume of the box? Alright, so we are going to take or create a picture of this. And then it says it's a square-based box. So we are going to pick the same variable for the base. And the height could be anything, so we're just going to do h there. Now for for a box like this, we know that the volume is going to be normally length times width times height. But in this case, we know it's going to be w squared times h, because w is going to be both the length and the width here. And so this is what we are trying to maximize. Now the constraint here is the surface area. Now the surface area, if you think about it, the top of the box here would be w squared. That's the area of the top. And we're going to have a top and a bottom of that box, so we're going to have two w squareds. And then if you think about each of these sides, all of these sides are going to be h times w for their area. So we actually have 4 h times w's there. So we know the surface area is 96. So that's going to be our constraint. And just as before, what we're going to do is I'm going to choose to get h alone, so that I can just plug in, if I have h, I can plug in whatever I get into my maximization problem. So I'm going to do 96 minus 2w squared, and I'll write it 4wh. Then I'm going to divide by 4w on both sides, which means that h is alone. Now, I'm going to substitute that into my volume problem. So instead of h, I'll write 96 minus 2w squared all over 4w. Now if I distribute the w squared in, I will have 96w squared minus 2w to the fourth. Okay. Now I can do a little butterflying here. Now I know 96 over 4 is 24, and w squared over w is w. Now if I do the other side, you're going to do minus 2 over 4 is just 1/2, and then we're going to have w cubed. Now with the animal pen problems, we were able to use the vertex trick. But here we have negative 1/2 w cubed. This is no longer quadratic. So we have to resort to a calculator at this point, or we have to go to decimals. I would use your calculator to find the maximum, because on a test you won't be able to use decimals. So we have decimals pulled up here, and going back to the problem, we are going to put negative 1/2 w cubed plus 24w into decimals. Oops. Plus 24w, right? Yes. Alright, and our job here is to find the maximum. Now again, it doesn't make sense to have negative x's. We are only thinking about positive. And so between 0, 0 and 6.928, we should have a maximum. Okay. So what I'm going to do is I'm going to change the settings here. I'm going to make the y-axis be much taller because our graph is going off the top of the window. And so now I've selected a window that shows me the maximum. And the maximum here is 4. Now 4 is the width that will give us the best dimensions of the box, and the volume then will be 64. So based on what they're asking for, if they ask for dimensions, you have to use 4 as W. If they want the maximum volume, it's going to be 64. But let me go back and just make sure, because if W is 4, I have to go back maybe to this right here to figure out what the height is. I would do 96 minus 2 times 4 squared all over 4 times 4, and I'd have to work that out to get my height. That would be 96 minus 32 all over 16, which would be 64 over 16, which is actually 4. So the dimensions, if you want to know the dimensions, it would be 4 by 4 by 4 tall, which would be volume of 64. So some things that might change here, though, is that in the future, maybe they would say that the top is open. So maybe when you would do the formula, instead of 2w squared, because your box is then open like this, you would want to just say 1w squared for a square base, and then plus 4 of the sides. So it's like the pen problems. They might adjust it a little bit. You just have to make sure your constraint and the volume works out and it matches what they're describing.